Okay, form 1. Right, we talked about this on the other video. If you have log equals number, you rewrite it as an exponential. Okay, form 2. If we have log equals log, that's even easier because the logs in essential cancel each other out and you just set your arguments equal. Okay, but you can only have one log on both sides. So notice here on example A, how many logs are on the left? 2 logs. So we're going to have to use our properties of logs to condense these 2 logs into 1 log. So if I have log plus log, how do we condense that situation? That becomes multiplication of the arguments, right? Addition becomes multiplication. That's one of our properties of logs that we have studied. So this becomes the log of 3 times x plus 4. When we condense a log that is being added, that becomes the multiplication of their arguments. The log of 3 times x plus 4. Okay, so now we have log on the left and log on the right. So I can eliminate both of these and solve the equations as they are. Okay, so these are the easy kind. Once you do your condensing, right, we have to combine the logs to have only one log. So now it's just a matter of solving this. So x equals 7. Okay, let's move over and look at another one. So here we have a log, once again, plus. How do we combine if we have a plus? Multiplication. So I'm going to multiply x plus 2 times x minus 3. So now I have 1 log on the left and 1 log on the right. So I can essentially cancel out our logs and solve what's left over. So we're going to solve this by making and factoring a quadratic. Okay, this one's worth talking about. We make a quadratic because we have an x squared and an x and a number in our equation. So we factor the quadratic and we get 2 answers from your quadratic. Okay, but then here you have to remember you cannot take the log of a negative. When you plug -4 back into your equation, you get log of negatives. So we have to throw away the answer that does not give us a real value. So the only answer to this quad problem is x equals 5. We cannot use them both. Okay, in simplifying this one, notice we only have log on one side of our equation. And we want to condense that log, and we start by taking this 2 and making it into a power. Okay, we start by using the properties of logs in order to condense these. This is 3 to the 2nd power. Okay, well, I know what 3 to the 2nd, hopefully you do too. What is 3 to the 2nd power? That's 9. So I can rewrite that as just the number 9, and that makes it a little bit easier to look at. Okay, so now I have natural log minus another natural log. And what does minus become when I combine these things? They become division. So this is the natural log of x divided by 9 equals 2. Okay? So the first thing we do when we have multiple logs is to combine them by using their properties. So now I have natural log equals 2. How do I go about solving it when I only have one log? I want to rewrite this as an exponential. I rewrite it as an exponential if I only have one log on one side. So what's my base for natural log? That's base e. So e to the second power equals x over 9. E to the second power. Anytime we have log on one side only, you want to rewrite it as an exponential. And our last step is going to be to multiply by 9. Okay, which you can't actually do, so you're going to have to be satisfied with 9e squared as your answer. Your calculator can do that for you, but we're smart enough where we can leave that alone as an answer and be satisfied. So here I have 2 logs on the left and 1 log on the right. So I need to condense my 2 logs into 1. So the first step is to bring my multiplier to be a power. So this is going to be 2 to the third power, which is what as a number?
8.
That's 8. So this is going to be log base 4 of 8. And then when I condense, subtraction becomes division. So my final answer when I combine this is going to be log base 4 of x divided by 8 equals log base 4 of x plus 7. So now I have log on both sides. So in essence, I can cancel both of these out and just solve my algebraic expression. So let's multiply both sides by 8. Right? That's how we get rid of that denominator. So x equals 8x plus 56 when we distribute that 8 into both of those things on that side. Then I'm going to subtract my 8x over here. 1x minus 8x is negative 7x. And my last step would be to divide both sides by negative 7, and x equals negative 8, which should raise some red flags. Right? X is a negative number. What happens when I plug x of negative 8 back into my equations? I get negative logs. Right? So because x equals negative 8 is my only option, that means I have no solution whatsoever. Even though negative 8 is an answer, it does not provide a positive value when you plug it back into your equation, so there's no solution. Okay, let's change gears for a second and solve some exponential equations. Okay, now these ones can be tricky if you don't know your bases, because what happens is, the idea is pretty simple, that if the bases are equal, okay, so we have a base of 2 and we have a base of 2, right? That's equal. That's pretty easy to see. If the bases are equal, then the exponents must also be equal in order for the entire equation to be equal. Okay? So our job with these exponential equations is going to be to manipulate our bases somehow so that they have the same number. Because when bases are equal, your exponents must also be equal. Okay? So that's going to be the goal for the rest of these problems, is to do some base manipulation. We want to change whatever number we have so that they're the same. So something raised to some power. Right? We're going to be changing these around so that we get something raised to a power, and those bottom things are going to be the same. So notice here I have a base of 8 and I have a base of 2. Right? So 2 is a prime number. Chances are that's going to be the base that I want to keep. So how can I write 8 as 2 to some power? Right? That's the first thing we have to do here, is change 8 into a base of 2. So 8 is 2 to the what power? 2 to the third power. Okay? So I'm going to replace 8 with 2 to the third. Now, what else was up there in my power already? 3x minus 2. So whatever is up there already becomes parenthesized, and you multiply it by the power that you just created so that our bases are now the same. So let's set our powers equal to each other. 3 times 3x minus 2 equals x plus 5. Okay, so once again, the hard part is making your bases the same. So we have to really focus on, can I write them as the same base? So this next one, I have 9 and 27. Okay, I can't write 9 as base 27, and I can't write 27 as base 9. So you have to know, right? You need to know that 9 is 3 to the second power. And you have to know that 27 is 3 to the third power, right? Because if you don't know your bases, if you don't know your multiplication, then these are going to be extremely difficult to do. Okay, so this is 9 is 3 squared, and I already have a 2x up here. Okay, and 27 is 3 cubed, but I already have an x plus 2 up in my power. Okay, so the only thing I do is I need to multiply my new power, which is 3, times both of those other things, right? Because if your bases are equal, then your exponents must be equal also. Okay, so x is going to be equal to 6. So those are the tricky ones, right? You have to make your own bases, so you have to know your multiplication to know which ones your bases are going to be, because when your bases are equal, your powers have to be equal also. Okay? Good luck with these. They are not straightforward.